X is given and temperature is given. We have to find pressure and Y. What kind of calculation is this?
Dew point.
Dew point. किसने बोला ये?
सर
अरे
पहले
किसने बोला?
दीक्षिता ने बोला।
हाँ
सर पहले दीक्षिता ने बोला था,
हाँ, बाद में किसने बोला?
बाद में मैंने बोला।
कौन है ये? I can't see, that's why I'm asking. निरंजन. Okay.
हाँ सर, पहले दीक्षिता ने बोला था।
हाँ, पहले दीक्षिता ने बोला, बाद में निरंजन ने बोला, राइट? दोनों रॉन्ग है. See, what we do is when we look at XY diagram or rather PXY and TXY diagram, याद है आप लोगों को? Does anybody remember? कहाँ गया phase diagrams? You remember this? Okay. बबल पॉइंट कर्व कौन सा है? Can you see this diagram?
TX curve.
TX curve, right? That is bubble point curve. और TY curve कौन सा है? Dew point curve, right? So we had said कि अगर if I start with suppose x1 here, this is the composition, right? Suppose I start with this one. X1 and I increase the temperature and I'll reach a point B where the first bubble will form. I know the composition X, right? And I know the pressure. Pressure is constant here. Whatever. I need to find the temperature and the composition of the vapor. तो कैसे पता करूंगा मैं?
No sir, temperature was given.
नहीं ठीक है ना, ये केस देख लो ना, वो बाद में देखेंगे. Let us understand this diagram first. So in this case, composition is given x1 and we are increasing temperature till we reach point B. Right? When the first bubble will form. And the bubble will have what composition? Point given by the tie line C.
Thailand.
Right? So liquid composition is B, vapor composition in equilibrium is C. This is given by the tie line. So this is called bubble point calculation. Temperature is given, it can be either way, pressure or temperature, doesn't matter, it is bubble point. So temperature is given, composition is given, we are finding rather composition is given, pressure is given. यहाँ पर pressure constant दिया है, right? ये pressure is given, composition is given, we are finding temperature and vapor composition. समझ में आया? So this is bubble point calculation. Right? Temperature. It can be for pressure as well as for temperature. अगर ये नीचे वाला देखा डायग्राम, if you see this one, now temperature is given, composition is given, I have to find the pressure, right? Pressure वहाँ निकालेगा मैं, इधर liquid, sorry liquid यहाँ है, so I am going from here till I reach a pressure at which the liquid composition can be found by the tie line. Right? So this is the liquid vapor composition then. This is a liquid composition, this is a vapor composition. So when temperature is given and we have to find a pressure, this is the Y curve, this is again bubble point curve. समझ में आया? Whether it is finding temperature or pressure, that is not important. What is important is liquid composition is given. We have to find vapor composition in equilibrium. That is the bubble point. Is this
Yes,
understood? Now, if I look at dew
Yes,
point,
sir.
dew point में क्या रहेगा? Vapor composition is given. So I'll start from here and increase the pressure till I reach this point, and then I'll draw a tie line which will give me liquid composition, which is given by this thing. So temperature is given, vapor composition is given, I have to find the liquid composition, px curve. So that is dew point calculation. समझ में आ रहा है? Because I am touching the dew point curve and then drawing a tie line from there. Is this understood? Difference between dew point and bubble point calculation.
Yes,
याद
sir.
रखने का, जब लिक्विड कंपोजिशन दिया है, वेपर फाइंड करने का है, दैट इज बबल पॉइंट, बिकॉज ऑलवेज लाइक वी से द फर्स्ट बबल कब फॉर्म होता है लिक्विड में से, राइट? सो लिक्विड कंपोजिशन इज नोन, वेपर कंपोजिशन इज नॉट नोन, वी आर फाइंडिंग द वेपर कंपोजिशन, दैट इज बबल पॉइंट ऑलवेज. ड्यू पॉइंट कब होता है? वी टेक द वेपर एंड कूल इट, और विच से कि हम प्रेशर रिड्यूस करेंगे और अदर इंक्रीज करेंगे, तो कब वो फर्स्ट ड्रॉप ऑफ ड्यू या फर्स्ट लिक्विड ड्रॉप बनेगा वेपर में से, दैट इज ड्यू पॉइंट. सो वेपर कंपोजिशन इज गिवन, वी हैव टू फाइंड लिक्विड कंपोजिशन, दैट इज ड्यू पॉइंट. Pressure temperature is not important, it can be anything. Important thing to remember is x is given, find y, that is what? If x is given, I have to find y, what is that? If x is given, I have to find y, what does it mean?
Bubble point,
bubble
sir.
point
आंसर करो ना
calculation.
भैया, अगर समझ में आया तो. And if y is given, I have to find x, what is that?
Dew point.
Dew point. So understand that bubble point, dew point का अगर आपको definition समझ में आया तो you can always say that correlated कि क्या calculation कर रहे हैं हम. ये x y temperature is not important. What is important is x is given, find y. X is given, find y, that is bubble point, and y is given, find x, that is what? Y is given,
Dew
find
point.
x क्या? Dew
Dew
point.
point.
Right? समझ में आ रहा है ये? Temperature pressure is irrelevant. What we are looking at is composition जो दिया है, liquid का दिया है, vapor का find करने का, that means it is bubble point. Vapor का दिया है, liquid का find करना, that means it is dew point. इतना याद रखो. बाकी temperature pressure is not important. वो एक दिया रहेगा, दूसरा find करने का आपने को. एक TXY कर रहेगा, एक PXY कर रहेगा. Okay? Is that clear?
Yes, sir.
Any doubts on this? Okay,
No,
let
sir.
let us move forward now. So now we have considered ideal solutions, but again, we always start with the ideal because that is the simplest case to handle in any situation. But real systems are not ideal, so we have to actually handle non-ideal systems, and that's what we'll see, how to handle non-ideal systems. Okay, so ideal solution के लिए हमने Raoult's law apply किया था, where we assume that gamma is equal to 1, right? We have taken this as gamma equal to 1, right? Ideal solution के लिए. Understand this, right? And we know that pi bar is partial pressure वगैरह वगैरह सब पता है आपको, right? And if we take non-ideal solution, the partial pressure does not vary linearly with concentration. This is due to dissimilarities in molecules वगैरह वगैरह सब देखा हमने, right? So non-ideal behavior. So light hydrocarbons in heavier paraffins, right? See, simpler molecules, similar molecules will be ideal, which are dissimilar, light and heavy है, उसमें non-ideal होगा. Difference in molecular weight रहेगा. Suppose I take methane and I take decane. There's a vast difference in molecular weight. Structure is totally different. So it will not be ideal solution. Okay. Intermolecular attraction forces will be there. Hydrogen bonding will be there. All these things will create problems, and that is why we need to have non-ideal solutions. ठीक है, ये देख लिया हमने. So there are different types of non-ideal solution. One is positive deviations from ideality, and other one is negative deviations from ideality. So when the actual partial pressure is greater than partial pressure calculated by Raoult's law. Raoult's law से हम partial pressure calculate कर सकते हैं, right? Pi bar is equal to xi pis, right? If you know pis, that means if you know vapor pressure of component I, and if you know the mole fraction in the liquid phase, we can calculate the partial pressure in the vapor phase, right? So when the actual partial pressure, measured partial pressure, is greater than the pressure calculated, partial pressure calculated by Raoult's law, वो इक्वेशन जो दिया था हमने ऊपर, if it is greater than this equation, then it is positive deviations from ideality. Okay, and solution of intermolecular forces between like molecules stronger than unlike molecules. So examples दिया है, ethanol water, ethanol ethyl ether, CS2 acetone, benzene cyclohexane, different examples. To understand कि अगर actual partial pressure is greater than the partial pressure calculated by Raoult's law, it is positive deviations from ideality. Greater means positive, and negative is if it is less than actual partial pressure is less than the partial pressure calculated by Raoult's law. Simple definition. Actual is more than ideal. Raoult's law is ideal, right? So if actual is greater than ideal, then it is positive deviations. If actual is less than ideal, then it is negative deviations. Okay, and examples are given here: chloroform, ethyl ether, वगैरह 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 वगैरह. ठीक है, different examples. ठीक है, समझ में आया डेफिनेशन ऑफ पॉजिटिव डिविएशंस फ्रॉम आइडियलिटी एंड नेगेटिव डिविएशंस फ्रॉम आइडियलिटी?
यस सर.
ओके, सिंपल है, याद रखना चाहिए आपको. ओके, सो नाउ इफ यू लुक एट द px diagram, you are looking at CS2 acetone system. Okay, and that means you are plotting the pressure on the y-axis and liquid composition on the x-axis, right? Raoult's law में क्या है? Pi bar is equal to xi pis. So if you plot this, ये जो curve है, this is for CS2 and this is for acetone, right? And if you draw a straight line from 0 to vapor pressure of CS2, you get a straight line. And similarly, if you draw a straight line from 1 to acetone का vapor pressure, you get a straight line. And that straight line represents Raoult's law. याद है किसी को? बताया था मैंने. I had shown you before, right?
Yes, sir.
Right. So when you say vapor pressure of CS2, that means it is 100% CS2 here. It is pure CS2. So जो total pressure रहेगा, that is equal to vapor pressure of CS2. Pure CS2, one composition of CS2 is 1, right? And if I take CS2 composition 0, that means acetone कितना हो जाएगा? It is CS2 acetone system, right? When CS2 is 0, how much is acetone in the solution?
1.
1. That means it is pure acetone. यहाँ पर that is vapor pressure of acetone, right? And this is a straight line essentially. If y-axis is Pi bar, that means straight line ड्रॉ किया xi pis, straight line ड्रॉ किया तो xi pis हो, there is no intercept, right? समझ में आ रही बात? If I take this equal to xi equal to, suppose I say xi equal to 1, right? ये लिया मैंने, यहाँ पर 1 डाला, तो what I get, pi bar is equal to pi is at xi equal to 1 for CS2. Similarly, if I take acetone, if xi equal to 1 for for acetone, if I put xi equal to 1, I'll get pi bar for the solution is equal to vapor pressure of acetone. Is this understood? Raoult's law gives straight line between partial pressure and liquid composition. Now, if you see this curve, actually, partial pressure of CS2, it is above that diagonal line or straight line, right? That means at any point, if I take suppose any X composition, right? Suppose if I take this value of X, so by Raoult's law, I'll get this value of partial pressure, and actual is this value. समझ में आ रही बात? So actual is greater than ideal or greater than the value given by Raoult's law. ठीक है? Similarly for acetone.
Yes, sir.
Similarly for acetone, if I draw a line like this is the value given by Raoult's law and this is the value given by actual measurement. So actual is greater than Raoult's law, right? So this is positive deviations from.
सर तो
क्या बोला?
एक्चुअल में गामा आएगा ना?
हाँ, वो देखेंगे बाद में. We'll see later. Now we are just looking at experimental observations. We are not talking about gamma now. Gamma will come later. I have not talked about gamma at all. Only ideal में gamma equal to 1 होता है. We'll see what is gamma. We'll introduce that also. But gradually, now we are looking at only experimental observation. Experimental observation. If you actually measure the partial pressure on in a solution of CS2 and acetone, we'll find that actual partial pressure measured is greater than what is calculated by Raoult's law. Is this understood?
Yes.
Okay. So if it is understood, then let us go to the next part, which is negative deviations from ideality. Okay, positive deviations from ideality में ठीक है, थोड़ा एक part और है. So if we take total pressure plot किया हमने, see this was only P2 bar X, right? If you look at this one, this is P2 bar versus X, this is P1 bar versus X. But if we add P1 bar plus P2 bar, P is equal to P1 bar plus P2 bar, right? Total pressure of a system, binary system, is always sum of partial pressures, Dalton's law, right? So if I add this value, if I take any composition, let me take it to the top. If I take any value of X, I know what is P2X, right? I know what is P1X. If I add this, I'll get total pressure. यहाँ पर scale नहीं आया बराबर, but that is how you get total pressure, Px curve. There's total pressure versus X. Similarly, Py curve भी आ सकता है. Okay. So this is what we get for total pressure भी ऐसा convex रहेगा ऊपर में. Okay. because this is convex. You see this is convex, this is also convex, तो ये भी convex रहेगा. Is this understood? Positive deviations from ideality. Any doubts on this before we proceed further? Okay. अगर नहीं है तो let us see. Negative deviations में क्या होगा? Same thing. We plot the partial pressure P1x and this is real जो concave कर रहेगा नीचे, and this is ideal straight line वाला जो मैंने explain किया. Same concept है. Straight line is your ideal, this is ideal, and this is your real. ये वाला real है. So it's going to be below that straight line. That means if I take any value of x, if I take any value of x, then this is the value given by Raoult's law. This is the actual measurement, right? So actual partial pressure is less than that value given by Raoult's law. Similarly, this is the value actually measured, and this is the value given by Raoult's law, right? So it is always less than what is calculated by Raoult's law. So that's why it is negative deviation of ideality. और ये कर्व भी negative यानी concave रहेगा. This concave curve. Total pressure का भी concave रहेगा. Is this understood now? Positive and negative deviation of ideality. Any doubts, questions before we proceed to the next part? So looking at the curve of partial pressure versus x or total pressure versus x, we can say whether it is positive or negative deviation of ideality. ठीक है? Okay. So once you understand that, let's go to the next one. Yes.
ये डेविएशंस किसकी वजह से हो गए? मतलब
बताया ना,
अभी वो P1 बार एक
नॉन आइडियल सॉल्यूशंस क्यों होता है? Whether it is positive or negative, it is non-ideal, right? Non-ideality क्यों होता है? अभी एक्सप्लेन किया ना मैं थोड़ी देर पहले. Why solutions when solutions are ideal and when they become non-ideal? Who can answer this? Devendra?
Sir, when we take into account the intermolecular attractions, they become non-ideal.
Yes. When the molecules are similar in size and shape and composition, they form ideal solutions because attraction forces are not too many. When they are dissimilar molecules, अभी बताया example मैंने, ethanol, water and all, these are all dissimilar molecules. Similar molecules like pentane, hexane, heptane, octane, these are all similar molecules. Close molecular weight is almost similar. Heptane and octane का molecular weight ज़्यादा फर्क नहीं है. If I take ethane and methane, similar structure, molecular weight is not too different. But if I take methane or methane and heptane, even heptane, there's a lot of difference between molecular weight. So they'll form non-ideal solutions because of changes in structure, changes in molecular weight, different attraction, repulsion forces are there, and that is what creates non-ideality. ठीक है?
Yes sir.
Okay, so let's go to the next part now. Once we understand this, now we'll talk about azeotrope. Azeotrope सुना है आप लोगों ने? What is azeotrope?
Yes, sir.
क्या होता है azeotrope?
So, azeotropic distillation.
हाँ?
Distillation.
Sir, azeotrope is the mixture which is not to get separate. मतलब हम लोग उसे separate नहीं कर सकते.
Separate नहीं कर सकते. क्यों नहीं separate कर सकते?
उसका boiling point nearly same हो, उससे close होता है.
डिफरेंस कम होता है सर बॉइलिंग पॉइंट.
बॉइलिंग पॉइंट डिफरेंस कम होता है। ठीक है, देखते हैं, लेट्स सी। ओके, सो इट्स अ कांस्टेंट बॉइलिंग मिक्सचर। एज़ोट्रॉप मीन्स कांस्टेंट बॉइलिंग मिक्सचर। जैसे हमने अभी देखा था, इफ यू रियली रिमेंबर, इफ यू रिमेंबर फेज डायग्राम्स, एक्स वाई डायग्राम, so if you look at this is equilibrium diagram, right? XY diagram, याद है? So if I take any liquid composition, suppose I take this liquid composition, right? Sorry. इस liquid composition में the vapor composition is given by this point. ठीक है? So if this is x1, the vapor composition in equilibrium is given by this one. That is the purpose of y-axis diagram. You can find out what is the equilibrium composition of liquid and vapor for any. If x1 is known, you can find out y1. If y1 is known, you can find out x1. So if we see x1 की वैल्यू अगर सपोज 0.6 है ये रफली, तो y1 की वैल्यू रफली कितनी होगी? लुकिंग एट जस्ट स्केल, 0.8 समझो, राइट? डजंट मैटर, जस्ट लुकिंग एट नंबर, अप्रॉक्सीमेट नंबर्स, राइट? स्केल देख कर रख रहे हैं कि ये सपोज ये 0.6 है तो ये 0.8 होगा। दैट मीन्स y1 इज ग्रेटर देन x1, बराबर? This is actually your tie line, x1 y1, right? So if I'll take a liquid of composition x1, I'll get a vapor in equilibrium which is composition y1, which is x 0.8, 0.6 लिया x1, तो y1 0.8 आएगा. That means I get a vapor which is richer in which component?
More volatile component.
More volatile component, right? So if I take a mixture of two liquids, x1 and x2, or any two components, and I increase the temperature, right? So I'll get at that equilibrium, I'll get 0.6 रहेगा liquid composition, तो उसे equilibrium में जो vapor रहेगा उसका composition रहेगा 0.8. So if I take that vapor and condense it, right? Liquid का vapor जो है distillation का वही करता है, right? You take the vapor and condense it. If I condense this vapor, I'll get a liquid which has composition 0.8, and this is starting point is 0.6. That means I have increased the concentration of more volatile component in the product. समझ रहे बात? That means I have taken an impure liquid. ये एक स्टेज है, this is one stage of distillation column. Distillation column बहुत stage रहता है. But in one stage, I have actually increased the concentration of more volatile component from 0.6 to 0.8, right? So this is normally what happens. But azeotrope में क्या होता है? You get the same composition of the vapor. 0.6 लिया, अगर azeotrope फॉर्म होता है तो 0.6 लिया तो वेपर भी 0.6 ही रहेगा. That is what is called azeotrope, constant boiling mixture. Liquid composition is same as vapor composition. It is not different. अगर एजियोट्रॉप नहीं है तो ऐसा होगा, 0.6 का 0.8 होगा. अगर एजियोट्रॉप होगा तो 0.6 का लिक्विड लिया हमने तो एजियोट्रॉप रहेगा तो वेपर भी 0.6 ही बनेगा. दैट मीन्स आई कैन नॉट increase the concentration of more volatile component in an azeotrope. समझ में आई बात डेफिनेशन एजोट्रॉप की? So it is a constant boiling
Yes.
mixture. It is boiling without change. So there is no change when we boil it if it is azeotrope. So when an azeotrope is vaporized, हेलो,
Yes, sir.
क्या हो गया था? मेरा बैटरी डाउन हो गया था लैपटॉप का, तो चार्ज किया. ओके. So in a azeotrope, it's a Greek origin. It means boiling without change. There is no change when you boil it. So when an azeotrope is vaporized, vapor has same composition as the liquid. That is the definition of azeotrope. तो बताया मैंने, अगर 0.6 लिया लिक्विड में और अगर उसका एजियोट्रॉप बनता है तो दैट मीन्स वेपर आल्सो विल हैव ओनली 0.6 कंपोजिशन.
सर
ओके. या
रिवर्स बोल सकते क्या उसको, दैट द लिक्विड हैज सेम रिवर्स लिक्विड हैज सेम कंपोजिशन एज पेपर.
बस कट हो रहा है.
हेलो
हाँ बोलो.
सर, जैसे हमने बोला ना वेपर हैज द सेम कंपोजिशन एज द लिक्विड, जैसा रिवर्स बोल सकते हैं क्या कि द लिक्विड हैज द सेम कंपोजिशन एज वेपर?
अरे लेकिन लिक्विड लेके इवेपोरेट करेगा तो ही वेपर मिलेगा ना. रिवर्स भी ट्रू है ना, वेपर लिक्विड सेम है, यानी क्या इक्वल है ना. x1 इक्वल टू y1. व्हाट आई मीन इज x1 इक्वल टू y1. समझ में आ रहा है?
यस यस सर.
ओके.
सर
यस.
सर इस केस में पी सैचुरेशन म्हणजे वाई सैचुरेशन और वो प्रेशर सैचुरेशन अपन टोटल प्रेशर सेम कैसे होगा?
हाँ, क्या बोल रहे हैं?
सर हम इक्वेशन लेते हैं ना y इक्वल टू पी सेट अपॉन पी इंटू एक्स. तो सर इस केस में पी सैचुरेशन अपॉन टोटल प्रेशर सेम कैसे होगा, म्हणजे उसका फ्रैक्शन 1 कैसे आ गया?
ओके. सो लेट अस सी क्या इक्वेशन है. y i p इज इक्वल टू x i p i s, इसकी बात कर रहे हो?
हाँ सर.
ये लेकिन this is applicable only for ideal solutions, no? This is only for ideal solutions. We are talking about non-ideal solutions. Non-ideal के लिए क्या होता है? What is the equation of non-ideal solutions?
सर गैमा है होगा, y p
Gamma
इक्वल टू
आएगा.
गैमा है.
So where is the question of that being equal? समझ रही बात? This for non-ideal.
हाँ यस सर.
मतलब सर एजोट्रोप कंडीशन सिर्फ नॉन आइडियल सॉल्यूशन के लिए आएगा क्या?
Yes, बोल रहा ना पॉजिटिव डिविएशन फ्रॉम आइडियल, नेगेटिव डिविएशन आइडियलिटी, क्या मतलब क्या उसका? Azeotrope is non-ideal. We are just talking about a specific case of non-ideality. Non-ideality is always there but azeotrope is one specific case of non-ideality. Only at a particular composition of liquid X you will form a azeotrope. पूरे रेंज में नहीं आएगा, एक पर्टिकुलर कंपोजिशन पर ही azeotrope फॉर्म होता है. You'll see that between 0 to 1 there will be only one composition of X1 at which azeotrope will be formed, whereas it is non-ideal over the entire range. समझ रहे हैं ना बात? Non-ideal का मतलब क्या है?
Yes, sir.
Partial pressure is greater than partial pressure calculated by Raoult's law, right? That's what the definition of non-ideal, right? Positive deviation रहेगा तो partial pressure actual is more than what is calculated by Raoult's law. Negative deviations is when partial pressure actual is less than that calculated by Raoult's law. That is the definition of non-ideal, right? Positive and negative. But now we are talking about azeotrope. Azeotrope is one particular case of non-ideality. It may be positive, it may be negative. We'll see that. Let's not talk about positive negative. It means that only at a particular composition of X, paper composition is same as X. Y1 equal to X1. पूरे range में नहीं होगा. It will be only at a particular composition. We'll see that examples also. Just understand, azeotrope means when X1 is equal to Y1. ठीक है? Is this understood?
Yes.
So azeotropes
Yes,
are
sir.
formed by solutions having large positive or negative deviation from ideal. It could be positive or negative, doesn't matter. But it is very large deviation, that is why azeotrope is formed. Okay. So when we have a maximum in vapor pressure curve, जो हमने देखा plot किया ना, partial pressure versus X, right? एक convex आ रहा था, एक concave आ रहा था, right? When you have maximum in the vapor pressure curve, it is called minimum boiling point curve. प्रेशर ज़्यादा है तो बॉइलिंग पॉइंट मिनिमम होगा, और अगर वेपर प्रेशर से कॉन्केव था, दिस कॉन्वेक्स, राइट, दिस कॉन्वेक्स कर्व, तो इट इज मिनिमम बॉइलिंग कर्व, एंड अगर मिनिमम वेपर प्रेशर रहेगा तो दिस इज कॉन्केव, राइट. तो दिस कॉल्ड मैक्सिमम बॉइलिंग पॉइंट मैक्सिमम रहता है उसका. ठीक है. So we'll see that what is minimum boiling azeotrope and maximum boiling azeotrope. One is called minimum boiling azeotrope. That means positive deviations from ideality. देखो positive is actual is more than ideal, तो convex रहेगा. So if you take PXY diagram at constant temperature, so it is convex curve. तो ऐसा curve change हो जाता shape. It is not जैसे हमने देखा था ना, it was like it was we had like this, right? This was our normal curve, right? बट यहाँ पर क्या हो जाएगा, ऐसे जाके ऊपर जाके मैक्सिमम से बाद कम हो रहा है फिर से. तो दिस इज और पॉजिटिव डिविएशन फ्रॉम आइडियलिटी, बट that will result in minimum temperature. Instead of this type of curve, you get this type of curve. It's called minimum boiling azeotrope because the temperature is less than that of both the solutions, both the solvents, right? अगर टेम्परेचर XY ड्रॉ किया हमने तो सेम थिंग उल्टा हो जाता कर्व. प्रेशर में मैक्सिमम रहता है यहाँ पर, तो वो पॉइंट पर टेम्परेचर मिनिमम हो जाता है. सो दिस इज T1 इज व्हाट इज दिस T1? What is T1?
Boiling point of A. Yeah. More
Boiling point of 1, component 1, right? Because this is X equal to 1. And this is boiling point of component 2, right? So this temperature जो है ये actually boiling point है azeotrope का. At this point the vapor will be formed, which will have equal composition, liquid and vapor, and that is why it is minimum, it's less than T1, less than T2. That's why it's called minimum boiling azeotrope. Deviations are positive because pressure is more than ideal carcass यहाँ पर, right? Pressure is more, that's why it is positive deviations from ideality, but temperature is less than that of pure 1 and pure 2, and that's why it's called minimum boiling azeotrope. Is this understood?
सर यहाँ
Yes.
पे 1 और 2 जो है उसमें मोर वोलेटाइल और लेस वोलेटाइल कुछ है क्या?
अरे किस दुनिया में है रे रितेश? This is always x1.
X1 ना? Yes sir.
We
Yes, sir,
always
got it.
plot x1 on the x-axis. What is x1?
Yes, sir.
x1 क्या है?
Mole fraction of more volatile.
It is always more volatile component. We always
More
plot
volatile.
more volatile component. That is why this temperature of more volatile component T1 is less than that of T2.
Yes sir. Got it, sir.
ठीक है, किसी को डाउट है मिनिमम बॉइलिंग एज़ोट्रॉप के ऊपर? समझ में आ रहा है?
सर एक बार प्लीज रिपीट कर सकते हो?
Okay, so if we look at PXY diagram, that is at constant temperature, or positive deviation of ideality means the curve is convex, right? देखा था हमने. So this is a type of curve which we see, and what happens when there is an azeotrope formed? Actually ये जो है ना ये ऊपर वाला PX curve है, right? This PX curve, this PY curve, right? So if you see at this point, ये दोनों curve merge हो रहे हैं, PX curve and PY curve, right? So at this point, if you take this is x1, y1, right? X-axis पे, right? If I take PX curve, x1 is this value. If I take PY curve, y1 is this value, right? So what does this mean? At this point, x1 is equal to y1. बराबर है?
Yes sir.
If you look at this pressure, xy pxy curve, ये दोनों curve, px curve and py curve are merging at that point. That means if I take any liquid of composition x1, I'll get a vapor of composition y1, which is same as x1. हमने देखा था azeotrope का definition, right? Liquid and vapor composition is same. यहाँ पर if you look at this partial pressure versus temperature xy diagram, you'll see that pressure is not changing, or rather partial pressure is same for x and y. So we get a composition of vapor which is same as liquid. And if you plot the same thing on a TXY diagram, you get उल्टा हो जाता है, pressure ज़्यादा है, temperature कम होता है, right? So if you draw this, you'll get this kind of curve. यहाँ पर भी temperature जो रहेगा, temperature of liquid and vapor is same. ठीक? यहाँ पर दोनों आके दोनों curve, TX curve and TY curve दोनों merge हो रहे हैं यहाँ पर. So temperature of the liquid and vapor is same, and you'll get this at this point an azeotrope which is boiling at temperature which is below that of pure component 1 and pure component 2. That is why it's called a minimum boiling azeotrope. Composition same है, x1 equal to y1, temperature is also less than that of component 1 and component 2 both, and that is why it's called minimum boiling azeotrope. Understood?
हाँ sir.
Okay, so now if you plot xy diagram for the same thing, अभी तक txy और pxy देखा, but if you try yx diagram, this is yx diagram, or XY diagram, which we call it equilibrium diagram. तो क्या होता है? What will happen is, if you take this one, this will go up and then it will cross over. यहाँ पर cross हो जाएगा. It will go below this curve. यहाँ पर positive deviation from ideality है, यहाँ पर negative deviation from ideality है. याद आ रहा है? And at this point, x equal to y और x1 equal to y1. ये पॉइंट पर.
सर
Yeah.
सर हम एजोट्रॉप पे दो वो कंपोनेंट है सेपरेट नहीं कर सकते ना?
वही तो बोल रहा है, x1 equal to y1 सेपरेट कैसे करें?
हाँ
हमने देखा था ना, y equal to x जो थे डायग्राम देखा था. We have seen that diagram, right? कहाँ गया? यहाँ पर suppose I take this diagram and I draw a line from x equal to whatever. Suppose this point 3. तो y कितना आएगा? 0.7 करीब आएगा, roughly. So in this case, if I take a liquid of 0.3, I will get a vapor of 0.7. So if I condense the vapor, I will get a vapor which has more of component 1 than component 2. Whereas in this case, and for a particular composition, that is for only this composition of x1, vapor is same as x1. बाकी जगह नहीं है. यहाँ पर देखेंगे, if you look at here, look at this point, suppose at this point my vapor is going to be richer than that of, sorry, at this point the vapor is going to be richer than the liquid. बराबर. So यहाँ I can get a separation. I can take this x1 at 0.3 and maybe I'll get 0.6 and vapor. But at this point of composition, there is only one composition मैं बोला था. It's not throughout the range of the composition. It is only at one point in that composition where azeotrope is formed, and that is always fixed for a system. Depends on the composition of the depends on the liquid and vapor, liquid 1 and liquid 2. So at that particular composition only where azeotrope is formed, and that is always fixed. If you look at examples, ethanol water will form azeotrope only at 89.4 mole percent ethanol. That is the only composition where ethanol water will form an azeotrope, or 95.6 volume percent ethanol. बाकी जगह पे नहीं होगा. Right? That is why ethanol water जो maximum जो मिलता है without by distillation you get is maximum you get is 89.4% ethanol. You cannot get more than that because इससे ज़्यादा होगा ही नहीं. You get this composition of the vapor.
हेलो सर.
Yes.
हेलो.
हाँ सर, वो एजियोट्रोपिक पॉइंट के बाद जो है वो लेस वोलेटाइल कंपोनेंट का फ्रैक्शन वेपर में ज्यादा हो जाता है क्या?
Yeah. If you look at the diagram, yes, vapor का composition कम हो जाएगा.
For less volatile component, it increases.
Yes. But वो क्या होता है कि वो constant यहाँ पर constant boiling हो जाता है, इसके बाद इधर जाता ही नहीं है. It doesn't go this way. It remains at this point. Because distillation continuous process रहता है ना, feed आते रहता है, product जाते रहता है. So it is always at steady state. Composition does not change. Okay. Distillation करेंगे ना जब हम we operate at steady state. We don't operate at steady state. तो स्टेडी स्टेट जो रहेगा मैक्सिमम यहीं पर मिलेगा, यहाँ पर इससे ज़्यादा जाएगा ही नहीं, बिकॉज इट इज स्टेडी स्टेट ऑपरेट. ज़्यादा लेके कोई फायदा नहीं है अपने को, बिकॉज देन आई विल गेट लेस इन द वेपर फेज. मैक्सिमम आई कैन गेट इज 89.4% इथेनॉल.
सर फिर वो क्यूएस कैलकुलेट कैसे किया है?
Yeah, see, that is experimental data. You can always calculate, but you're not going to operate the plant at that region. Data gathering is different. Plant is different. This is thermodynamics. We always study thermodynamics, then we design the plant. System study
Yes, sir.
karna
Yes.
is laboratory. Plant is always actual. So we are not going to operate in this region because it's not going to get anything any better.
मतलब सर एजोट्रोप पॉइंट पे ही हम डिस्टिलेट निकाल लेंगे सब, उसके आगे जाने ही नहीं देंगे।
उतना मैक्सिमम हम ले सकते हैं बाय सिंपल डिस्टिलेशन। देयर इज एजोट्रोपिक डिस्टिलेशन, उसकी वो यूज किया, एक और सॉल्वेंट यूज किया, तो यू कैन गेट 99% इथेनॉल आल्सो, which is what is normally practiced in industry. If you want to get 99% alcohol, you do azeotropic distillation or some other form of distillation. But by simple distillation, जो हमने देख रहे हैं, you can get maximum 89.4% of ethanol. There are other methods to solve this problem. ऐसा नहीं है कि प्रॉब्लम को सॉल्व नहीं होता है, but not by simple distillation. Okay, we have to add a solvent. Benzene add किया तो होता है, break होता है azeotrop, and then you can get 99 point something ethanol. But that's a different topic. ठीक है?
Yes, sir.
Is this understood? So there are different examples given here.
Yes,
concept
sir.
is important. So next one is, I want to finish this today. Maximum boiling azeotrop. वो minimum boiling था, right? Temperature was less than both the components. The maximum temperature is more than both the components, right? And this for negative deviation from ideality. And total pressure of system is less than ideal value. देखा था हमने definition of non-negative deviations. So if we take PXY diagram, concave curve आता है, and again just like that one, PY curve and PX curve will merge at this point. So at this point it is x1 equal to y1, and this is 0 to 1, and this is x1, right? Exactly similar, only thing is shape of the curve is different. वो convex था, ये concave है, यहाँ पर merge हो रहा है, और ये जो TXY diagram draw किया, again similar to that one. At this point, again these two curves will merge, temperature will be same for the liquid and vapor, and what we'll get is x1 equal to y1. And because this is the boiling point of component 1, and this is the boiling point of component 2, and this temperature is more than both of them, that's why it's called maximum boiling azeotrop, right? The temperature जो है, this temperature is more than T1 and T2. And that's why it is called maximum boiling azeotrop. समझ में आया? अगर ऊपर वाला समझ में आया, नीचे वाला is just extrapolation of that, और कुछ नहीं है, उसका उल्टा. Shape of the curve is exactly ulta of the previous one. Concept is similar. Boiling point is more than component 1 boiling point and component 2 boiling point. That is what is called maximum boiling azeotrop. When the boiling point is less than component 1 boiling point and component 2 boiling point, is minimum boiling azeotrop. Just remember that minimum boiling means temperature कम है, maximum boiling means temperature ज़्यादा है. ठीक है? और ये हमने अगर XY डायग्राम ड्रॉ किया तो ये भी उल्टा हो जाएगा. उसमें ऊपर से आके नीचे जा रहा था, यहाँ से नीचे जाएगा ऊपर जाएगा, फर्क इतना ही है. यहाँ पर भी ऐसे होगा, दिस इज x इक्वल टू y. At this point, x1 equal to y1. So this is the composition of the azeotrop. शेप सिर्फ उल्टा हो जा रहा है, बाकी सब सिमिलर है, कॉन्सेप्ट इज सेम. To understand maximum or minimum boiling, you understand maximum boiling.
तो इस केस में सेपरेशन कम होगा.
सेम है, you'll get only azeotropic composition. Distillation से you'll get only composition azeotrop. ये जो composition है इससे ज़्यादा मिलेगा ही नहीं आपको. Same case, whether it is this way or that, doesn't matter. उससे आगे जाएगा ही नहीं. Because if I start with this composition, suppose I start with this composition, right? Maximum I'll get is this one. उससे ऊपर जाएगा ही नहीं. because at this point steady state आ जाएगा उसका, जैसे जैसे पहले वाला देखा था हमने. कहाँ गया पहले वाला? Because if I start with this, then maximum I'll get to this one. इसके ऊपर जाएगा ही नहीं वो. एक बार एज ड्रॉप बन गया ना, उसको ब्रेक करने के लिए we have to use other methods of breaking it, which is called azeotropic distillation. उसमें एक सॉल्वेंट ऐड करते हैं, दूसरा सॉल्वेंट which will break the azeotrop and form another azeotrop. तो आप थर्ड ईयर नहीं, मास ट्रांसफर 2 में पढ़ेंगे, सॉरी सेकेंड सेमेस्टर में, azeotropic distillation. ठीक है. So examples are given here and temperature भी दिया है. इसके बाद का concept I think we'll start tomorrow, but understand what is minimum boiling azeotrope and maximum boiling azeotrope. ये concept समझ में आ गया. Actually problems जो हम करेंगे, we are not going to look at minimum boiling, maximum boiling, we are going to look at only azeotrope. But एग्जाम में आ सकता है आपको minimum boiling azeotrope क्या है, maximum boiling azeotrope क्या है, राइट शॉर्ट नोट्स वगैरह आ सकता है. Azeotropes का अगर आ गया, राइट शॉर्ट नोट ऑन azeotropes, so you have to write all these things. But examples में we'll look at only azeotropic composition where x1 equal to y1 and use that point, because there's only one point in the entire composition range where x1 equal to y1. We'll use that point to do the VLE calculations. We'll start that tomorrow. ठीक है. Any questions, doubts?
सर और एक डाउट था. सर अगर हम दो इमिसिबल लिक्विड लेते हैं तो उनका मिक्सचर का सर बॉइलिंग पॉइंट उन दोनों से कम आता है ना?
Immiscible liquid का separation नहीं होता. Immiscible liquid separation is not done by distillation. You can do separate gravity separations कर सकते हो. जैसे ऑयल और वाटर लिया तो रख दिया तो ऑयल ऊपर आ जाएगा, वाटर नीचे आ जाएगा, राइट? यू डोंट नीड डिस्टिलेशन फॉर दैट. दिस इज ओनली फॉर मिक्सेबल लिक्विड सेपरेशन. डिस्टिलेशन इज ओनली फॉर liquids which are miscible with each other. Immiscible liquid के लिए डिस्टिलेशन कोई जरूरत नहीं है करने की. जैसे ऑर्गेनिक और वाटर लिया, राइट? इफ आई टेक हेप्टेन एंड वाटर, आई डोंट नीड डिस्टिलेशन. उसको रख दो, ऊपर हेप्टेन आ जाएगा, नीचे वाटर आ जाएगा, सेपरेट कर लो. ठीक है. Any other questions?
सर
या
सर वो रॉल्स लॉ में वो जो डेविएशन वाला है ना, उसमें अगर एक बाइनरी मिक्सचर है तो फिर एक कंपोनेंट पॉजिटिव डेविएशन दे रहा है तो दूसरा कंपोनेंट नेगेटिव दे सकता है क्या?
जनरली नहीं होता ऐसा. We'll see that when you look at activity coefficients tomorrow. जनरली नहीं होता है. जनरली सेम ही रहता है. I mean पॉजिटिव रहता है, दोनों पॉजिटिव रहता है, दोनों नेगेटिव रहता है. बट आई डोंट नो अगर ऐसा कोई रेयर केस है कि पॉजिटिव नेगेटिव, तो आई डोंट नो. जनरली दोनों का सेम रहता है.
कैसे?
बट विल सी, देखते हैं कल. बिकॉज आई हैव समथिंग ऑन एक्टिविटी कोएफिशिएंट, दोनों में सेम ही आ रहा है. दोनों का जनरली सेम ही रहता है. पॉजिटिव रहेगा तो पॉजिटिव रहेगा दोनों का, और नेगेटिव रहेगा दोनों का नेगेटिव रहेगा. Because it is interaction. Ultimately, it depends on structures of the molecules and how they interact with each other.
Okay, sir.
Okay. Any other questions? Okay. So I'll stop the recording.